Hey guys, today we're going to talk about triangles and how to classify triangles. So to classify a triangle, there's really two ways that we can go about it. We can classify by the angles inside the triangle, their measurements, or we can classify by the sides on the outside. And the sides have a special relationship with the angles that we'll talk about when we do them. But let's start off by talking about the angles. So let's say we have a triangle. Triangle, we'll call it ABC. And in triangle ABC, let's say angle A, angle B, and angle C. Angle A, angle B, and angle C are all acute angles. Each one of them is acute or less than 90. That would make this what we call an acute triangle. An acute triangle, you have all angles less than 90. So you're going to have 3 acute angles. That's our first way to classify. Let's say we have now another triangle. We'll call this triangle DEF. And we're going to have a nice little right angle here. So in triangle DEF, where the measure of angle D, in this case, equals 90, it's a right angle. We would call this, because we have that right angle, we would call it a right triangle. But we need to think a little bit about what every right triangle is going to have. So there's going to be one right angle, but we can't have more than one right angle. So it's going to turn out that these two angles are both going to be acute. So we have one right angle and 2 acute angles. And the reason why, if you have one right angle, if let's say somehow this was another right angle, when you're trying to find the sum of the 3 angles, you would have one right angle plus 2 right angles plus whatever the third angle is. No matter what value it is, it's going to end up being more than 180, and it can't be more than 180. It has to be equal to 180. So we're never going to have a triangle with 2 right angles. And if you think about how to draw that, well, here's one right angle. If you drew another right angle, you're not going to make a triangle. Both of these sides are going to infinitely go on. They're never going to cross and create the triangle. So you can't have a triangle with more than one right angle. You'll add up to more than 180. So there's our right triangle. Our last one, we'll say it looks like this. And we'll go back to ABC. ABC. In triangle ABC, let's say, for the sake of this, angle C is an obtuse angle, meaning it's more than 90 but less than 180, then we would call this an obtuse triangle. And for the same reasoning as a right triangle, you're only going to have one obtuse angle, and you're going to have 2 acute angles. Now, something to look for, like a pattern, every single triangle is always going to have at least 2 acute angles. If it also has a right angle, then it's a right triangle. If it also has an obtuse angle, like this guy right here, then it's an obtuse triangle. If it has 3 acute angles, then it would be an acute triangle. Okay, so those are going to be our 3 ways to classify by angles. Write them right up here. Acute, right, and obtuse. So if we're thinking about the angles, those are our 3 ways to classify. Now let's talk about if we're thinking about and looking at the sides. And for the sides, we're actually also going to look at the angles as well, because sometimes the angles will tell you how to classify by the sides as well. So let's say we have a triangle ABC, and none of the sides are different. They all have different measurements. Each side has a different length. We would call this a scalene triangle. That has 0 congruent, that's our symbol for congruent, sides. Now a way to mark this is you put these, what we call them, congruency markings. So if anything is congruent to this side, we put one marking, but since nothing is, we're going to put 2 markings here, 3 markings down here, meaning this is just saying they have different side lengths. Now another way to figure out if something's scalene, we're going to go right back to our same triangle, ABC, is you can look at the angles. There's 0 congruent sides. If you have all your angles are different measurements, 0 congruent angles, then it's going to be scalene as well. So if you have this angle is different, and these are called congruency markings, use more markings if you want to show that they're not congruent. If every single angle has a different measurement, it's going to end up being scalene because every side will have a different measurement. There's actually a really special relationship between the angles and the sides of a triangle. So if everything has a different measurement, we call it scalene. Our next type. Let's say we have triangle, and we'll go DEF here. Triangle DEF. And let's say in triangle DEF, not B, DE is congruent to EF. This is a congruent statement. DE is congruent to EF. That means DE and EF have the same measurement. We can mark that by putting these congruency markings. So now we have 2 sides that are congruent to each other. Well, our special name, when we have 2 sides that are congruent, is an isosceles triangle. Isosceles, kind of fun to say. An isosceles triangle has 2 congruent sides, and we're going to look into this more in the future, but they also have 2 congruent angles. And the relationship between the angles and the sides, well, the angle that's across from this side, like diagonally across down here, that angle is going to be congruent with the angle that's across from this side. So these 2 angles are going to be congruent to each other because like their opposite sides are congruent to one another, which can be really useful when trying to find measurements. So if you have sides, one pair of congruent sides will tell you it's isosceles, but also if you're given angle measurements, if you have 2 congruent angles down here, that means it's going to be isosceles as well, because their opposite sides will be congruent. Some really cool things with isosceles triangles. Our last way to classify now, and let's go back to ABC. In triangle ABC, if AB is congruent to BC, and that's congruent to AC, AB is congruent to BC, is congruent to AC, all sides are congruent, we call that an equilateral triangle. So an equilateral triangle means we have 3 congruent sides, and if you want to think about it with the angles, that would mean you have 3 congruent angles. It would mean you have an equilateral triangle. There's actually a fancy name for having 3 congruent angles, or all angles congruent. It's called equiangular. All the angles are equal, but we classify the triangle as equilateral. And in an equilateral triangle, since all the angles are congruent, we actually know each one of them is going to be 60 degrees, which is really nice to know as well. So this is our third way to classify by the sides, or sometimes really using the angles as well. We have scalene, isosceles, and equilateral. So I'm going to write those over here. When you are classifying a triangle, you're going to use one of each, one of each category. And what I mean by that is you're going to choose one of these green words, and you're going to choose one of these blue words. So you could be like an acute scalene triangle, or a right isosceles triangle, or an obtuse scalene, or an acute equilateral triangle. You're going to have combinations of them, but you're going to have one from here and one from here. So let's look at our first example of now using these classifications, combine it with what we did yesterday a little bit. So our first example, we have a triangle. Looks like this. We have X down here, we have 75 degrees up here, and 60 degrees over here. And we're going to use one of each one of these. So first, let's figure out what that angle X is down here. From what we did yesterday, 75 plus 60 plus x should equal 180. Triangles add up to 180. When we add over here, we get 135 plus x equals 180. Subtract, and you're going to get x is 45. So x is 45 degrees. Let's say we go by angle first. So looking at the angles, 45, 75, and 60, well, all three of those are acute. We have three acute angles, so this triangle is an acute triangle. But let's also choose one of these words. Looking at the angles, we have three different measurements, so nothing is congruent. That's a scalene. So this is an example of an acute and scalene triangle. So acute and scalene, and then our job is done. So again, we want to use one classification from each, by angles and by sides. But for by sides, you could use the angles like we did here, because the measurements are going to relate to the angles. All right, on to our second one here. Oh no, took away equilateral. We have, in the second one, triangle XYZ. The measure of angle X is 102. The measure of angle Y equals 39. And the measure of angle Z is, we don't know. And we want to classify. So our first thing should be to figure out the measure of angle Z. We know 102 plus 39 plus the measure of angle Z, and write it like that, equals 180. So over here, when we add together, we should get 141 plus the measure of angle Z, that equals 180. Subtract your 141 from both sides. The measure of angle Z should equal 39. So our measure of angle Z, now we know, is 39 degrees. You can double check by adding together and see if you equal 180. And when you do so, you'll find out you do equal 180. So now we have all the angle measurements. Well, let's go up here. Is it acute, right, or obtuse? Well, acute would mean all the angles are acute. That's not the case. We have an obtuse angle, so we should jump into obtuse here. This is an obtuse triangle, but we want to add more than just that classification. So are all the sides going to be different? Are there two sides that are congruent, or are there three sides that are congruent? We can use the angles. Notice we have two congruent angles, so there's going to be two congruent sides, meaning this is going to be isosceles. So this triangle would be an obtuse isosceles triangle. All right, on to our next one. So our next one, we have this triangle. And in this triangle, we have 4x, x plus 25, and this is just giving us 45 degrees. And we want to classify. So we need to figure out some angle measurements. Let's go ahead and make an equation. All the angles should add up to be 180. So we can say 4x plus 25 plus 45. That should equal 180. So 5x plus, well, 25 plus 45 is 70, equals 180. So 5x is equal to, when you subtract 70, you get 110. So x, when you divide, you should get 22. So x is 22. So let's substitute back in and find out some angle measurements. So if x is 22, then over here we get 47. 22 plus 25 is 47. And when you substitute over here, you should get 88 degrees. And if you want to double check to see if that works, it's always good to double check. 88 plus 47 plus 45. And we'll see if we end up with 180. And when you add these, well, 47 plus 45 is 92. 88 plus 92, well, that is 180. So these are the correct measurements. We did the work correctly. And now classifying by angle, well, they're all acute. So these are all acute. And then classifying by sides, well, they're all different measurements in the angle, so the sides will be different measurements. So we call that scalene. And there we go. So you can classify simply by substituting to find different measurements. You also can classify, sometimes it's really quick, if you have different shapes with markings on them already. for example, let's say we have this triangle. We can go ahead and try to classify. We can't classify by the angle here because we don't have any measurements inside, but we can classify by the sides. And this one, you have two sides that are congruent. You would call this one isosceles. If, let's say, we had maybe some angle measurements like this, you would classify this triangle. Notice how they each have a different number of markings. That signifies they have different measurements. So this has 3 different measurements, so we would call this triangle scalene. Again, we don't know the measurements, so we can't go by the sides, or by the angles inside. We don't know their measurements. And let's say we have this one. I want to talk about this one. If we have this triangle, well, we have 3 equal sides, so we would call it equilateral. And we actually can also classify this by its angles, because every equilateral triangle, every single one of these, all the angles equal 60 degrees. The measure of every angle will always equal 60 in an equilateral triangle. So an equilateral triangle is always acute, which is something that's really nice to know. Alright, so if you're feeling okay with these, you want to try some on your own, feel free to. If you want some more practice, I'm going to go through those 5 problems that are on the last slide. So if you want to try them on your own, then you can check and see the explanations that I have here. If you're feeling okay and you want to go into IXL, then go ahead. Have a nice day. So looking at these 5 problems, I'm going to go through the first one. And we're just trying to classify these. So find the value of x and then classify the triangle. So for our first one, we're given 50 degrees and 30 degrees. So for x, if you've done this one already, you should get 100. So this triangle would be scalene. All the measurements are different. And it's also obtuse. So it's an obtuse scalene or scalene obtuse. The order doesn't matter, but you want to make sure you have both. All the measurements are different, and there is an obtuse angle in there. For number 18 on this slide, we have, looks like this. We have 30 degrees, 85 degrees, and x. So when you find your value for x, you're going to say 85 plus 30 plus x equals 180, or you could say 115 plus x equals 180. And when you go ahead and do that, x should equal 65. So this would be an example. Well, all the measurements are different, so it's scalene again. And all the measurements are less than 90, so it is acute as well. So this is an acute scalene. Now for the bottom 3, we are given just the angle measurements, not a picture of the triangle. So the first one we have 70 degrees, 60 degrees, and x. When you add these together and subtract from 180, you should end up with x equals 50 for this one, which means it's going to be both acute and scalene. That was number 19 on there. Number 20, we have the measurements 60, and then we have the measurement 30, and we have x in the front. So 60, 30, and x. When you go ahead and add these together, you should get x is equal to 90. So this is going to end up being a scalene, but it's going to be a right triangle. So a right scalene triangle. All the measurements are different, but one of them is 90, so it's a right scalene triangle. Alright, and our last one, we have the measurements of 25, oh we had x in the front, x, 25, and 30. So let's go ahead, 130. So when you go ahead and figure out what x is here, well, 130 plus 25 plus x equals 180. 130 plus 25 is 155 plus x, and that's 180. So x should be equal to 25. And that means we have two congruent angles, which means we'll have two congruent sides. So it is isosceles. Oops. And since we have one angle that's greater than 90, it's going to be an obtuse isosceles triangle. And just like that, you are all done. Alright guys, have a nice day. Go ahead and practice a little bit, and we'll build off of this more next week.